All right, welcome everyone. Tree path array. All right, this one was made by Nook. So let's just take the challenge. I think it's always easier to sort of see it from the types and from the tests. So we have example here on line 4, and in it we have foo, and then inside of foo we have bar and baz. I always forget Mike. It goes foo, bar, baz.
Quux is one. Yeah, I've seen quicks. They're called metasyntactic variables, to my knowledge.
I knew you would know what that is. You're such a nerd. I love it. That's awesome. Okay. There's another weird one that's like 4 letters after quux too. Anyway, I don't know. But all the same, we have type of example on 16 here, and then we pass in foo and then bar. And what we're expected to get back is A. So we haven't seen this before. This is expect extends. So I'm gonna like jump into this. So it is what it sounds like. We have an expected thing that comes second, which I find counterintuitive, but we're expecting that the second thing that like the thing that we pass in first goes in the right side of an extend statement. I don't know. It could have been written a different way, I suppose, but that's how they chose to do it. So like, let's take a look. I think like what might be interesting is to take a look at some of these other ones. So we see that we have a union here. If we look at just like type of example, maybe A4 is the best one. We see that here we have basically a union of all of the possible paths recursively, like deep paths for a particular thing. So yeah, I don't know. How did I do explaining it? What do you think?
Yeah, I think that's a good explanation. We're trying to find a union of all of the possible paths, it seems, such that the first key is going to be like the first level of the object. The second key is going to be the second level.
Exactly.
Yeah, exactly. So it's sort of like a combinatoric expansion of all of the potential tree-like paths.
So, like broadly speaking, how would you approach this? What would you do?
Yeah, this one is tough. We know it's going to be recursive. We know that we're going to have to loop over each of the object keys. Mm-hmm. It seems like we don't need to deal with looping into arrays, so it's not going to expect us to like loop into subarrays and then calculate the numeric indices.
Yeah, not right now. Yeah. Just what's here.
So, yeah, I would begin with the age-old classic, looping over the or actually an accumulator is fine. I'm going to use an accumulator. Let's keep that in. Let's keep that
right.
accumulator in.
I don't want to direct you because there's actually this one is interesting because there's like 3 different solutions and they're all different approaches and they're all short. I mean, they're not. This isn't a super crazy one, but okay.
Yeah, let's see where we end up. I'll do K in key of T, and then say T of K. So we're looping over, and then we are just sort of saying the identity value. And now we kind of want to check. We first kind of want to have a base case, right? So I'm thinking if T is not an object. So if T is an object, so I'm going to say record string unknown. So if it is an object, we're going to loop through it. If not, we're going to, I reckon, return the accumulator. This seems sensible to me. And then
I think it's, did you pass? Is it passing? Wait a second.
Wait, no, it's definitely this shouldn't be passing.
Oh, it is passing by accident. I mean, I'm seeing it's passing, but it shouldn't be.
I'm also seeing it pass. It shouldn't be passing.
Okay, I don't know. Let's keep going.
Yeah. I want to. We can see what I'm gonna make a little type. No, I can just hover over A1.
Yep.
So looking at A1, hovering over A1. Yeah, let's see that. We are indeed getting an object, which we expect, but that's not actually correct. So now I kind of want to say, all right, we're going to loop through into ourselves in the path. So this should be nothing. We're not actually doing anything yet. And then I want to visit this accumulator, and I want to say we are appending to the accumulator. So I'm going to get the current state of the accumulator. Yeah, always happens.
Always happens, yeah.
And then we are going to pass in our k as a post-pended element. So if we hover over A1 now,
Yep.
We see that we are kind of getting that result, but that is not what we want to happen. Instead, we want to kind of unroll from this in a different way.
I have an idea. We could do this.
Yeah.
We could say key of t. Does that work? That works.
Oh yeah, that works. All right, let's.
Is that it? Oh, whoa. No, that's not it. It's
okay,
close.
Yeah. Let's see a more complicated example.
So yeah, A3 is failing, even though it doesn't show that it's failing, but it would be.
Okay, so we're looking at a bar to A, and then baz to B, baz to C. Why is it failing? Actually, what is wrong with it?
I guess that doesn't make sense to me either because key of T.
We also need to include the short paths. So we're only including the leaf paths, like the full paths, but we also need to include each of the transient nodes. So just doing this naively, I think if we save the state, if we like unionize the state that's such a weird. We're unionizing. If we kind of unionize the state as we're passing through. I'm actually thinking not like that. I want to. Maybe this is naive. Maybe either would work, but I actually want to put it in this accumulator section here.
That could work.
And if we hover over A3 now, this is interesting. We're getting also the empty tuple, which makes sense to me, but we're also getting all of the transient.
Should we put it here? Is that like totally wrong?
Let me see.
That's better. Bar, baz. Actually, it's correct, except that it contains the empty tuple. Oh no, it's not correct. Never mind.
Yeah, let's put it back where I had it.
All right, I'll put it back.
Just yeah. Can we get the test working?
I don't know how. No, I mean, I'm surprised that they're. So when I go through these, like I make sure that the tests pass, but I may not have. I don't know. Maybe I don't have 3. Can we? Would you mind if we looked at some of the solutions? Maybe we can.
Yeah, let's see what.
Yeah, because now I'm very curious. So okay, here's let me copy their name too. jiangshanmeta. No, they don't. I mean, I don't think TypeScript is. No way. Okay, wait a second. All right, let's grab let's grab all of them at once and put them on the screen and see. So let's comment that one. Let's comment this one. Do any of them pass? Is TypeScript failed in some way? This one does not.
Yeah, this one is pretty gross in terms of
the output. Yeah. Okay. Let's do. Maybe it's some artifact of the testing suite. This one looks like it works, except this one here is wrong. Type of path foo bar. This is wrong. The tests are also wrong. Look at this. Look at B4 is incorrect.
Oh, Z
is not anywhere yeah.
Oh,
so,
yeah, that's interesting. Okay, so yeah, there's a lot going on here.
So, all right, this is actually dramatic foreshadowing because one of the ones we're gonna look at, this is 2 from now, you and me, Mike, is like really broken, like actually broken. I think this is just mostly broken. Well, we have one solution that definitely works. Let's take a look at it. I don't know. You tell me. You walk me through it. Line 72.
Yeah. Let's look through. So we have T, which is our normal object that we're sort of looping over. And we have a P variable, which we're saying...
I made this little note. I just thought it was fascinating that you don't need the parens there. It's still...
Oh, gotcha. Yeah. A little bit of order of operations, yeah.
Yeah. Interesting.
Okay.
But
yeah, so initially we have this P extends P, which is pretty confusing. In what case does a type not extend itself?
Mike, I'm surprised you would say that. All that's doing. It was okay. So here's a question, because I've actually been thinking of making a video on this. Is it clear to you if it says that?
P extends any. Isn't any a super type of all types?
No, stop. You're thinking too hard. So the only reason for that statement is to trigger the distributive conditional.
Oh, fascinating. Okay. Could we go into what does distributive conditional mean again?
No, I mean, it's like when you have a union.
Yes.
So okay. P is a union of keys of T.
Yes.
Right.
I see. We're looping over the union. I see.
Yes.
I see. Okay. Understood. So we're looping over the union P.
Yes, and the recursion does happen here.
Okay. So the clause on line 74 never gets omitted? Question mark. I'm trying to understand. But they both get omitted. And then for one, we're appending it. So this is the equivalent to like the or, like the accumulator or logic.
So it's like, give us the current position, and then here's the recursion of the next one.
Yes, understood. It's interesting in that it doesn't store it explicitly as a tuple. Instead, it stores the tuple on the call stack, so to speak, which I think is, if less efficient. I would be interested in stress testing it.
Yeah, I don't know. I mean, this is the only one that doesn't have an accumulator, but now I'm like extremely I'm like extremely suspicious that the other ones just don't work, and I just thought they did because they passed the tests, but maybe the authors thought that as well. Look, they all say never. Okay. Let's look at what this person was at least trying to do. This is a very similar setup. So but they're using an accumulator, which I don't think you need. Let's put in like 1 here and see, does it change anything? No. Let's put in 2 here. Does it change anything? They all resolve to 2. So, string, I don't know if that would change anything. No, it doesn't, because it's the same basically for this purpose.
Yes.
Well, so this is a middle ground. I think this is like sort of passing things along, and then I don't know if you, I mean, I didn't ask. Do you have anything to say about this one compared to the other?
I think I like the fact that it's using an accumulator. I think it is benefiting, as far as I can tell, from the tail call optimization aspect compared to the bottom one, at least. Because if we scroll down to the bottom one, if we look at where we're calling ourselves in path, this is within the confines of a tuple definition and within the confines of a variadic operator. So it's going to, if we were doing like 50 elements, I think it would start failing, or larger objects. I think it would be interesting just to have like stress tests for these. I know that some of the problems do actually have larger inputs to
they do
validate that.
For sure.
But this one apparently does not.
All right. So that one's a fail. And then I think we did already look, but here we never really looked at it. But we have an accumulator. It's like a union accumulator. And then we're mapping through. I think this is this is the most similar perhaps to what you were working on.
Yeah, the only difference is I put the union inside of the path call while they're putting it on the outside.
Let's try to get yours to work then.
Yeah. In what way does my current one fail?
If we just do what you just said, the only way it fails is that it has an empty.
Oh, I mean, if it's a matter of the empty tuple. So this is just gonna, here. This is very simple, actually.
Okay.
This is kind of, so I'm gonna put this back for reasons I cannot explain. And then the way I do this, this is kind of hacky, but I would just do exclude empty tuple. And the reason that I do that, so that seemed to work, right?
Yeah.
And the reason that I'm doing it this way is because in my mind, if I were to design this type challenge, I would actually include the empty tuple as a potential, I think as a potential path, because mathematically that path arguably does exist. It's like the 0th element of the nulls. It's like the null vector of the space, right?
I will say, though, it is actually not passing because if you look at A3, we have the paths A, B, and C are there as separate things.
Yes. A, B, and C are... Oh, yeah, and that is not correct. So, yeah, let's do what you specified and say...
Well, wasn't my idea.
Yeah.
But let's see. I mean, it does look better. Oh, I guess it's correct. Bar, Baz... They're in a different order, but okay, yeah, that's the only change. But we still have our empty tuple there. So
yeah,
I guess.
Yeah. So the way I do this is if I really want to be sure I'm excluding something, I'll say I'll basically do this. Yeah, as another step.
I get you.
Yeah. So,
where's it actually being included? I guess it's being included the first time. Extends. You know what? What if we said, all right, I'll let you do that.
Yeah,
before.
So that's the like.
Okay, now it's all good.
Yeah.
Well, I have a question. Like, what would happen? Okay, we're like already going too far on this, but like, if I wanted to, couldn't I do that?
So then you're doing never or something. So that itself kind of, and we can't apply never is not a tuple, so we cannot.
Right, but wait, hold on. Does that work?
Let's rename path to C.
Well, sort of. What we want to do is this. Oops. Does that get us? Oh, because it has because never.
Yeah. It sort of looks.
All right. I'm the worst. Okay. Well, anyway, we did minimally solve it, everyone. Okay. Don't blow us up in the comments with your hate. So, I don't know. This one is a little tricky, but oh well, we did it. I'm pretty satisfied. How about you?
Yeah. This is a great problem.
Okay. On we go.